All right, hello. Good evening and welcome to Crossroads of Ideas, threading the story of Earth's oldest rocks. I'm Brooke Norsted. I'm the Associate Director of the UW Geology Museum. We're about 2 blocks from here. I need a show of hands. Who's been to the Geology Museum before? Oh, good. For those of you who did not raise your hands, consider this to be an invitation. We're open 44 hours a week. We're free. We've got dinosaurs, rocks that glow in the dark, the only piece of Mars you can see on display in Wisconsin. So even if you've been there, maybe you haven't seen the meteorite before. So tonight's event is a joint program between the Geology Museum and the Wisconsin Science Festival, and it marks this fall's first installment of the Crossroads of Ideas program series. The Crossroads of Ideas is a collaboration between the Wisconsin Institute for Discovery, the Morgridge Institute for Research, and the UW-Madison Strategic Communications. And it's an opportunity to foster dialogue between the community and UW-Madison researchers. The series addresses issues that matter to all of us and are also the subject of research at UW-Madison. Since 2014, Crossroads has been a staple of public programming offered at the Discovery Building. And for this special joint event today, we're excited to help support the 15th Annual Science Festival as one of the hundreds of events happening throughout the state over this 10-day span. I know for Sam, the coordinator, it feels like 10 years. So before I say more about this evening's event, we will take a moment to acknowledge the land that we occupy here at the Discovery Building. The Wisconsin Institute for Discovery at UW-Madison acknowledges that it occupies the ancestral lands of the Ho-Chunk Nation, known as Teejop, which means 4 lakes. The Ho-Chunk have stewarded this land and its waterways, Mendota, Monona, Wabesa, and Kaganza, since time immemorial, maintaining deep cultural, economic, and spiritual ties. We honor their sovereignty and the shared strength of standing together with all First Nations of Wisconsin. Now, to get to the subject you all came here for, tonight, you get to enjoy a conversation and a collaboration that is made possible by the National Science Foundation. The researchers here, Tyler Blum, Annie Bauer, and Emily Mixon, they all were funded by the National Science Foundation to study Earth's oldest rocks, the Acasta Gneiss. All federal grants require that a portion of their funds are dedicated to the broader impacts. And so that's really ensuring that there's a commitment for that group of researchers to communicate those findings and their research to the broader public, the taxpayers, so they know how their money is being spent. And so that's often where the Geology Museum and I get involved, is doing some of that translation of research, some of that sharing of the information to the public. So tonight is a real treat. For the past 3 years, I've been facilitating conversations between our geoscientists and Leah Evans, a local textile artist, with the goal of exchanging ideas and providing Leah with enough fodder to create a piece inspired by these conversations. The plan for the next hour is that first, Emily is going to introduce you to the rocks and the research. Then Leah will give you a little background on science and quilting and her work. Then I'm going to moderate a conversation where we're going to dig into some of the big questions that undergird this collaboration about deep time and the artistic and scientific processes. Then we'll get to see the physical product of those conversations, a new, unique artwork that Leah has made and will unveil tonight. We'll wrap it up at 8 p.m. No pressure, Leah, no pressure. We'll wrap it up at 8 p.m. and you'll have the opportunity to come up and look at the piece. Leah also brought along some of her sketches and some of her kind of in progress, so you can see some of her thinking. We also have a table where you can come up and learn a little bit more about the Acasta. You get to hold the oldest rock on the planet and ask questions. So we're going to get started with Emily introducing us to the science.
Thanks to Brooke for that introduction. I'm speaking on behalf of the science team, which is myself, Annie, and Tyler. And this was a huge portion of my work in my PhD over the last couple of years, which I finished in 2024. And Annie and Tyler were just immeasurable mentors during that time, as was Brooke, for learning about broader impacts. So I got to be involved in writing the proposal to do the science and the broader impacts. And so seeing this kind of from inception, actually writing it in our basements during COVID lockdown, to getting to talk to you about it tonight is really special. So thank you to Brooke for facilitating kind of the community that we've had around this project over the last couple of years. So tonight I'm going to be introducing you to the rocks and the research questions that were kind of at the heart of our project. So there are two main concepts I'm going to talk about tonight before we go to Acasta, and those are plate tectonics and deep time. So we're going to start out with plate tectonics. Some of you might be familiar with this concept, but it's essentially illustrated here by this amazing movie of the continents moving around. There's a lot of science underneath these plate reconstructions that different scientific groups around the world do. But the main idea is that we're all living on the Earth's crust, which is this really thin layer of Earth that floats around on top of the convecting mantle. I really like this quote here because it's from the 1800s, and so it shows that scientists and artists and even poets have been thinking about the kind of the observations that lead us towards plate tectonics for a long time, but it wasn't actually until the 1950s, 60s, and 70s that plate tectonics really became a scientific theory. And so one of the keystones of what is our modern plate tectonic setup is what we call subduction, which is shown here in this diagram in the corner. And that's essentially the idea that some crust, namely the crust underneath the oceans, is colder and denser, and it sinks into the mantle at places where the plates collide. And that's kind of the motion that drives what you're seeing in this, this GIF. And so what we're really looking for are signatures of subduction in these oldest rocks. And so to think about the oldest rocks, we have to think about geologic time. And so some of you might have seen different representations of the geologic time scale. Often these are artistic in nature as well. You can see one here on the side that's linear and is from artist Ray Troll. And you can see down at the bottom the Archean, which is really half of Earth's history, give or take. But it is compressed here at the bottom. And so I also like to look at a nonlinear scale, which Brooke has created for the museum. So you might have heard about this if you visited the museum. But the idea being that the start of Earth is down at your feet, and present, you're at the top of your head. So then you want to think about what are some things that you know about geologic history. A lot of people know about the dinosaurs. We like to ask kids, you know, where do you think the dinosaurs are on your body? A lot of them will point to their belly button or somewhere on their torso, but they're actually way up on your face. And so this just gives us a concept for this immense part of Earth history that we have a really hard time imagining and conceiving of, and we're going all the way back to down here at the bottom for the Acasta Gneiss. So if you get lost in deep time tonight, just think about your head to toe. And so putting these concepts together leads us to the heart of our research questions for this project. So we want to think about what were plate tectonics like on the early Earth, what sort of transitional plate tectonics took place to get us from whatever was happening when Earth first formed to the modern setup that we have today, and then what was the timing of these transitions? When did that transition happen? And so up here I have some artistic renditions of what Earth might have looked like at different times. You know, and if you visited Earth pretty much at any other point in geologic time, it would be like visiting a different planet. So I really like these. And so kind of the model behind our research is focused on asking this question about transitions. And so there are a couple of different proposed ideas for what plate tectonics might have looked like in the early Earth. One idea is what we'll refer to as stagnant lid. So that's the idea that the plates are not really moving around and interacting horizontally in the way that they do today, but that we're having the growth of crust kind of through these vertical plumes of volcanism, a little bit like what you might think of in Iceland or Hawaii today, but that being kind of the main mechanism for growing the crust. And then at some point, we start having more horizontal interaction, and that horizontal interaction is really important for what happens in the rest of Earth history, because that cycles carbon and other elements in and out of the mantle, creates topography like the mountain chains that we're familiar with, which interact with the climate, and in many ways make our Earth the habitable planet that we know it to be. And so we're looking as scientists for signatures of this subduction early in Earth's history. And so to do that, where are we going to look? We have to find the oldest rocks. So because deep time is so vast, it's really hard to find rocks that have been preserved for the entirety of Earth history. We don't actually have any that are the age of the Earth. You'll notice that Acasta is about 500 million years younger than the Earth. And so tonight we're going to be going to Acasta, which is in the Northwest Territories. And you can see where it falls on the time scale here. And so introducing Acasta as a place, Acasta was first mapped geologically in the 1980s by a group of exploratory geologists from the Canadian Geologic Survey. They were out just seeing what there was, kind of prospecting, and making a map that looks a little bit like the one I've shown here, all these different colors representing different rock types. And then we have some views of Acasta, both from an aerial perspective, what it looks like today, and then what some of the exposed rocks look like. And those rocks have since been dated to be 4.02 billion years old, which is quite old. And so before we can go into deep time, though, we also need to think about what scale of inquiry we're looking at for the rocks. So we have the outcrops, which you've just seen. We can go and look at the rocks, hold them in our hand, maybe powder them or crush them up from that scale. We can make really thin little segments of the rock, which you'll see over here on the table later, and look at the minerals and the composition that way. And then we can target specific minerals. We can crush up the rock, disaggregate it, and get out minerals that we're really interested in. And so what we're interested in tonight is a mineral called zircon, which is very tiny. The average size is the size of Lincoln's nose on the penny. But those little crystals have preserved primary geochemical information about the earliest Earth, and that's what we're probing. And so we mount them on pieces of sticky tape, take pictures of them, and then analyze them geochemically. And so how do we get the zircons out of the rock? Kind of a similar walk-through scale. We go out in the field, we collect the rocks, we crush them, we separate them with magnetism and density. I sit at a microscope and handpick them while listening to podcasts. And then we go and analyze them. And so Brooke mentioned the museum. A lot of you have seen the museum. Hopefully you've come in the front doors through the courtyard and seen this behemoth of a scientific instrument, which is the SIMS. And so Whisk SIMS is a really cool instrument. There aren't that many SIMS instruments in the world, in the country. And the fact that this one is accessible for you to go see on campus is really awesome. So I encourage you to go take a look at it. But basically this instrument shoots a beam of ions at our little zircon crystals, and it sputters off other chemical elements or ions that we're interested in. And then we measure them here at the end electronically. And so I'm going to show you the scale of some of these spots. So we can have spots that tell us about the age of the zircon, about the oxygen isotope composition, which I'll talk about, and about trace elements. And so we're really zooming far in at this point. And you'll see that in Leah's piece too, just the forecast. And so after we've done all this work, what has that told us about this bigger model? And so at the whole rock scale, we can look at evidence starting there. So we know that the earliest magmas at Acasta were formed quite shallow in the crust, so maybe that suggests that the plates were in that kind of stagnant lid scenario. And then they start to be originating deeper in the crust at about 3.6 billion years, and so something interesting is happening there. And so if we zoom into the zircon record, we see that that earliest period, there was actually geochemical signatures of rocks that are even older that we don't have preserved, but those were getting recycled. And then at that same 3.6 billion year mark, there's new crust that's generated, and then that newer crust starts getting recycled. And to us, as geologists, that's a subduction signature. That tells us that these crustal pieces are probably interacting more horizontally, getting pushed underneath each other, like we saw in that first schematic. Oxygen isotopes can tell us about if material is getting brought in to the magmas from the surface of the Earth, so that also tells us things are dynamic and interacting. So the oldest rocks look kind of like the mantle. The younger zircons have signatures that incorporate material from the surface, so again, kind of more dynamic interactions. And then interestingly, the zircon trace elements actually tell us that the entire history of Acasta, the magmas were incorporating some amount of water. And so this is really interesting to us and to people who think about how habitable planets are. You know, you saw that first picture of the Hadean Earth that looked like a hellscape. But other work from groups at Wisconsin and beyond has in the past shown that there was liquid water quite early on the Earth. And so we're seeing that manifest in an interaction between the surface and the deeper parts of the Earth at Acasta, which is one of my favorite discoveries. And so kind of putting it all together from the science perspective, rocks from deep time are really rare. We're really lucky to have gotten to work on some. Rocks from places like Acasta can tell us about these earliest processes. If we zoom into the zircon record, we can collect data that looks kind of like what I'm showing here, even though I didn't really show you data tonight. This is kind of how we build our story. And that tells us that there's some sort of transition happening early in the Earth's history. And so we can interpret this to say that there was a transition at Acasta at about 3.6 billion years from this kind of more stagnant environment to more towards the dynamic Earth that we have today. And so if you're interested in more of this, we'll be talking about it more. But with that, I just want to thank a lot of people who are not here tonight who've worked on this project. So all of the folks in the SIMS lab who really helped facilitate this research, as well as obviously the NSF and some other funding that really helped me during my PhD. So I will hand it over to Leah.
Hi. As a textile design student at the University of Kansas, I took a disproportionate number of math, science, and history classes. I randomly took a class on environmental history, and that changed my whole artistic focus. The environmental history idea of how land affects people and how people affect land has steered most of my work over the last 20 years. There you go. This piece is a good example of that work. It's an aerial view of coastal Louisiana, and it shows oil industry canals, but also the red stitching is like a prediction of how the land will change as sea levels rise. As a kid, I loved science. I spent hours playing in creeks, digging in the dirt, looking for fossils, and catching reptiles. And as a student, I loved science, but I had a hard time following lab instructions. So combining the aesthetics of science with art was my solution. Nature was a big part of my college years because I spent my summers working at Isle Royale National Park, where I got to experience wilderness and meet many interesting scientists that were doing research out there. Over the last 20 years, I've worked with a range of topics, including soil science, geography, lichens, water treatment, geology, and microbiology. This next piece is an image of an older piece of mine inspired by protozoa. I didn't have a background in microbiology, but I love playing with the imagery. So I borrowed elements from Ernst Haeckel's scientific illustrations from the late 1800s and played with them and made what I called fantasy microbes. After I would finish a piece, my biologist husband, Carrie Martin, would tell me what existing microbes they looked most like. Carrie coordinates Intro Bio 151 and 152, and he's one of the scientists I met working at Isle Royale. This piece shows an overlap of microbial images with a soil map. So it shows both micro and macro views of soil science, the landscape overview and the microbiological makeup of the soil. So there's some imagery that's taken from like the microscopic view of soil makeup, but then also looking at a soil map. The majority of my work has focused on human-made changes on the landscape. These pieces reference maps, satellite imagery, and aerial photography, but they also explore the influence of the landscape on people. In 2015, I was part of a competition through the Smithsonian Craft Show and a group called Honoring the Future. The challenge was to create craft work that addressed themes of climate change and sustainability, but also promoting sustainable practices while creating the work. Repurposing materials has always been a part of my art practice and is a large part of the history of quilting. So this is a specific piece I made for the competition based on the idea of habitat loss and also habitat corridors for animals to disperse, looking for new territory. It was inspired by work my husband, Carrie, had been doing using computer modeling to predict where wolves would disperse in Wisconsin as their numbers increased. My interpretation was abstracted and definitely an outsider's perspective of predator conservation, but it still spurred conversations with people viewing the work. I won the first year of the Honoring the Future competition and again in 2022. But my biggest takeaway from the experience was that I felt further challenged to create more work about environmental themes and to use more repurposed materials, so really trying to not buy new fabrics to create my work. In 2018, my family and I had the opportunity to visit Volcanoes National Park in Hawaii. We were blown away with the people, the cultural history, and the geology. So this is my youngest daughter, Ren, and I looking at lava flows in Hawaii. Within a year, I was making pieces exploring geomorphology. I looked at aerial imagery of lava fields, as well as USGS maps of volcanic craters, and created, this is a piece inspired by that, mostly a USGS style map, loosely referencing the active Kilauea crater and the nearby residential area of Volcano Village. And about 5 years ago, Brooke approached me with the possibility of working on this project, and I was super excited to actually work with scientists instead of just playing with the imagery to learn about someone's research and work from it. So this subsequent collaboration and conversation has inspired me to start speaking about science and quilting, which when I had that idea, I started looking for examples and actually didn't find that many, but this is Ellen Harding Baker. She was a Iowa mother. I think maybe she did some teaching, but she was really into astronomy and lost my place. So this is her solar system quilt from 1869. And news of her quilt eventually appeared in the New York Times on September 22nd, 1883. And the article reads, "Baker has a solar system worked in completely and accurately. The lady went to Chicago to view the comet and sunspots through the telescope that she might be very accurate. Then she devised a lecture in astronomy from it," end quote. She was likely inspired by Maria Mitchell, an astronomy teacher from Vassar College who had traveled to Iowa a decade earlier with a group of female students to view a solar eclipse. Mitchell was known to have a complicated opinion of needlework. As a suffragist, she saw the needle as a means of confining and limiting young women. But she also wrote in her diary, "The eye that directs a needle in the delicate meshes of embroidery will equally well bisect a star with the spider web of the micrometer." And I had to look up micrometer, which refers to a very delicate piece of equipment in an eyepiece with a telescope. So it had described as spider web thin wires in it. In writing this, she admitted that the discipline of needlework could help train the eyes and hands of future female scientists. And as Ellen Harding Baker proved, needlework could also be used as a teaching tool. The idea of a quilt being used as a teaching tool was something I experienced as a 5th grader in the late 80s. My parents took me to see a display of the NAMES project, the AIDS Memorial Quilt in Kansas City. Most of you who are old enough probably remember the AIDS quilt. It was conceived by Cleve Jones to bring attention to the crisis, but also as a means for healing for survivors. Each quilt block, as you see, there's groups laid out like a quilt block, represented about 32 people who died from AIDS. Each individual piece is about 3 by 6 feet, so the size of a grave marker. And it's the world's largest community art project. So medical professionals and news organizations early during the crisis were reporting that AIDS was a gay disease. Virology doesn't support this interpretation. Seeing the broad range of victims helped me understand and process what was actually going on. It countered the idea of a virus targeting a specific group of people. It was public health information and a call for funding for research. So I believe that this emotional response to quilts is one that a lot of people share. Quilts lend themselves to telling personal stories and social histories. And my hope with this project is that the piece would express the personal connections that geoscientists have to their work, address the idea of deep time, which is hard to wrap my head around, and to show the scale of place and materials involved. And that's it. Thank you.
Excellent. So that was just a little taste of some of the information that got shared in the conversations that we've had as a group. We've met together, we've taken Leah around the building and shown her all the lab equipment and the specimens. Leah has brought some of her work to the labs and to our offices and shared, not just completed projects, but projects that are in progress to show, some of the intricate and really laborious work. And getting really to kind of peek under the surface of that. And so where I would like to start actually in our conversation here is to ask Leah for your thoughts on parallels and crossover with the process that you take and what you got to see and kind of those conversations that you've had, the glimpses into the scientific process. Like, what are those parallels to your process?
I'd say the thing that stood out most is kind of the parallels in the gathering of materials, like gathering a sample, or for me, repurposing materials, just the stages in processing it and turning it into something or getting information from it, and just also that time for reflection. So as I'm doing these tedious elements of the piece, I'm thinking about what the scientists think about and their experience, in the field, processing, mounting all these tiny pieces. So that was kind of the main connection, I thought.
Yeah, there are definitely those same steps, right? Mm-hmm. Yeah, and I love thinking about you working on this piece and Emily sitting and like lining up all these zircon crystals for analyses. To turn the question to you all, what have you learned about, what are those crossovers between scientific process and Leah's process? Is there anything you would add on to that?
Yeah, I can add one thing. I think this probably became evident in Emily's presentation, but we're really enmeshed in the details all the time. And we're looking at something smaller than Lincoln's nose on a penny, and we're analyzing it at an even smaller scale than that. And then every now and then we have to kind of back up and look at the big picture. And that was really evident in her process for making this too, right? Like when you see the quilt, there's a lot of intricate detail in it. But she also had to think about the bigger story of how she was going to portray the science at the different spatial scales that we were doing it. And so that was one parallel that seemed really clear right away.
Mm-hmm. Yeah, scale is a big parallel here. I think that I remember that catching your attention really early, thinking about looking at these maps that are of continents, right? And then getting down to the actual objects of study. There's a really big scale difference there. Yeah. Is there any other parallels, Tyler or Emily, that come to mind?
We keep saying process, and that I think that's kind of the parallel here too, in terms of Leah trying to create something, and in our case, us trying to understand or organize our rocks and our minerals in a way that we can access them. And there's an incredible number of logistical challenges, and that became so evident when Leah brought things in and laid it all out, and we got a chance to see all the details that went into making things, part of the process of saying what will work, what won't work, trying to do something, going someplace else, or needing to do it differently, kind of rearranging the stitch and things like that. And that is something that we do constantly, kind of without just critical thinking and problem solving in moving forward with the process too. And then the thing that I like the best is when new ideas come up in the middle of it, and all of a sudden you start thinking about a project or a new way to do this and apply this in a different project in a different sense. And for us, we see things that all of a sudden we start thinking about new rocks and new projects and new ways to test the ideas that we're seeing and we're working with right here. And there's a lot of overlap and kind of on a broad scale in that sense too, which was actually really cool to see. There's such an interesting engineering of the artwork that was really, really cool to see behind the curtain, if you will.
I think the nonlinearity is really like what comes out for me, in that it's easy to look at like a science presentation like I just gave and see, oh, we had our research questions and our hypotheses and our materials, and this is what we learned, and it looks very linear. And often when you sit in a K through 12 classroom, you learn the scientific method, and it feels like this thing that you do A, B, and C, but really a lot like Leah's process of taking out stitches or finding new materials. That's really how science is done on a daily basis, kind of revising questions and revising models. And sometimes it's really hard to rip up the stitches that you thought you were going to be putting down, or to envision something new when you're presented with new information. So I really liked seeing that in her process as well.
Leah, you mentioned that you reprocess or you repurpose fabric, and I've seen photos of your studio, and I love thinking about these parallels between you, like, gathering your objects, right? Getting the fabric and storing it and sorting it and using it. And to me, I see connections with the rock cycle. And that a rock can change, right? It can be a sedimentary, a piece of sandstone, and then if it is subjected to heat and pressure, those sand grains fuse together and it becomes a different kind of rock. And here, you're taking these different fabrics and combining them different ways, taking maybe what used to be a pair of pants, and you're using it in a new object. I'm curious if you can tell us a little bit about some of the fabrics you used for the piece we'll get to see tonight.
Yeah, and I can be more specific when we're looking at the piece, but as a general rule, I would say probably about 80% of what I use is repurposed, either scraps from other quilters and dyers, upholstery shops. Dig and Save is a big source for me. So, it is like processing, sorting, taking garments apart, washing them, sometimes over dyeing them. But Brooke and I were talking about the materials, and there's actually, for the central piece of the quilt, it was one of the first things I did on its I guess I'll give it away, but it's a zircon granule. Kind of two different views of it combined. And that I had a few small scraps from a local quilter who does a lot of hand dyeing that were perfect for it, and I cut and combined those to kind of stretch them, but also create more interest with it. So that was a piece that I thought was kind of fun because it was very small, and I had to like work with it to stretch it. And it does kind of have this like, what did we call it? Like galaxy kind of look to it, which to me I love because these zircons are these tiny things that are holding so much information about the Earth. But,
Yeah, that scale again, right? Yeah. Annie, you've been to the Acasta. Can you tell us a little bit about that experience?
Yeah. When I went there to do field work. So I was going with a group of Canadian scientists from University of Alberta, and we took a float plane about an hour north of Yellowknife, and it landed in this bay, and it backed up, and it dropped us off on the beach with all our stuff, and then they said bye, and we weren't going to see them for a couple of weeks. And I'm from Seattle, and the first thing they had me do was learn how to shoot a gun, which I'd never touched or seen one before, which is because there are bears in the area. So we were camping on an island because it's harder for the bears to get out there. But the whole time we were there, it was just like a time filled with awe for me, where I could kind of slow down and think about what we were doing at a different rate than I could think about in my office. And also walking around and being like, maybe no one's ever stepped here before, or maybe I'm standing on an even older rock than we've ever dated before. And there's a lot of power in that thought, so it almost felt like a religious experience of sorts. Yeah, it was a really wonderful experience.
And at the point that you went there, you knew those rocks were that old.
Yeah, my PhD advisor was the founder of the Acasta Gneiss, which is a weird word. He did not create the Acasta Gneiss, but he's the person who first realized its antiquity. So he was working on younger rocks in the region. They were expecting these rocks to be younger, 1.8 billion years old, so still quite old. He hacked off a rock kind of haphazardly before jumping in a float plane, took it home and dated it. It was 3.5 billion, and it was kind of this whoa moment. And so then they went back and they did much more extensive sampling and recognized that these rocks were much older, and that it was kind of a window into these younger rocks that had been eroded down into the deeper part of the crust. And so that was a big surprise for him, and it made up a lot of his career, and he became famous because of it. So going there was also a really deeply personal experience for me, and seeing Leah's quilt was deeply personal. He had brain cancer while I was conducting my PhD, and so he had a really complicated health trajectory. And so being there was also like seeing myself in his shoes as a younger scientist and thinking about what it was like to be him and be there. And then seeing all the images that Leah took into her work was really powerful, kind of transformed through that experience.
Yeah, it reminds me of what you were saying about quilts being personal, right? And having these personal stories, and it's like your research is personal and professional.
Yes, exactly.
Right?
Yeah.
And it's woven into this quilt now. Thinking about mentorship, right? You were Emily's advisor, right? And so Emily, I'm thinking that we've got this lineage, which in academia, there's often this talk of lineage, right? I'm curious to be in that lineage and to think about, you've spent a lot of time thinking about deep time. You've spent a lot of time looking through a microscope, listening to podcasts, but I'm also curious, what else occupies your mind when you're working on these rocks and when you're picking through zircons? And
Yeah, I would say kind of building on that idea of melding personal and professional. I worked on some samples and zircons that Annie had worked on during her PhD that her advisor had also worked on, and so that was a really tangible way of feeling like I was collaborating with this broader scientific community. And I unfortunately never got to meet Sam, but obviously his foundational work is really important to mine, and so getting to interact with those physical materials was really unique. I think kind of like a lot of us do to cope with the expanse of time and what deep time is, you sort of start to anthropomorphize things, and so when you're looking at these really tiny crystals, it's like you think about how much time they've seen, and in this case, these rocks have also been reheated in geologic events, and they've been eroded, and just the fact that they're still intact and that the zircons are there holding onto this material is really like empowering in a way that they have like a hardiness and robustness that can feel almost inspirational.
Tyler, I'm curious to hear from you about how you were attracted to this work, to work on these special rocks. What drew you into this research?
So I spent my PhD working in deep time. In the first half of Earth history, not on the Acasta Gneiss, but for many of us who live in that space, places like the Acasta Gneiss are legendary. And so having an opportunity to work on those rocks when Annie came here and knows them so well was fantastic. And not just that, but the Acasta Gneiss is really unique in a number of ways, not just in the story of how it was discovered, not just in its antiquity, but there are mineral grains of zircon that are older than it. There are other places that are almost as old as the Acasta Gneiss. But here we have a package of rocks that have a shared history, and that turns out to be really powerful for a lot of things that we do. There's this very, very old piece of the crust that has a shared history and isn't just kind of specks of dust here and there. And so for some of the work that we did, that's extremely important from the context of that complexity is very challenging, but the fact that we have this coherent package of rocks, it gives us a chance to try to take that complexity and make sense of it. And that is even more rare when we go back and further in time. And so it's that part of the process combined with the timescales that we're talking about is, I don't know, it's really interesting. And the other piece of it is that they're just challenging rocks to work with, period. And I'm not one to shy away from that. That gets me amped up.
Yeah, that's one of the things I didn't talk about in the science talk because we just have no time for it. But we had to spend a lot of time essentially looking for the primary information. It's not just sitting there. And so we do all of this screening. We do a lot of measurements that are focused on essentially convincing ourselves that we're seeing something primary, and kind of like the quilting almost, and like finding these side projects that Tyler mentioned. Like, to us as scientists, that alteration and those complexities are interesting in their own right. And so it's almost like being a kid in a candy shop. Like, you can get distracted by this really cool alteration thing that happened maybe 1 billion years after the zircon was grown. But then you have to remember that you're like on your original mission. And so I think that's been one of the really enjoyable things about working on these rocks, and also at the same time very frustrating.
Yeah, it reminds me, Leah, of you've told us about that in the past too, of, you know, like having your primary focus. Like, I have this project that I'm working on, but like, ooh.
Yeah.
But this, yeah, there's something that takes you in a different direction.
Yeah, and all these conversations before I even started the piece for the project spurred an interest in just learning about basic geology. So I have basically a whole series of work for the last 2 years that's been about just kind of playing with the geology imagery and learning a little bit, definitely not an expert, but and then hearing people respond to it at shows and
Yeah,
trying
it's
something
been,
new. Yeah.
right, there's been these little nuggets that show
Yeah.
up in your work that I think have really excited all of us when I see some of your new work. Yeah, it feels like we got you at a really opportune time.
Yeah.
I saw you were doing that work in Hawaii, and I was like, ooh, now's the chance to get Leah involved. I think we should see this new piece. So Sam is going to, oh, I didn't give her a heads up. Sam's going to come and spin this around, and then Leah, maybe we've got slides that you can show off too.
Oh, of the
So-
details.
Yeah.
So do
So
you want-
as that spins around, can we flip to the next slide, perhaps? Right. Oh my goodness. Oh. You have the clicker? So this is the full piece, but yeah, Leah, do you want to walk us through this a little bit?
Yeah, so what, after years of conversation, one of the first images, I don't know what will be on here.
I kind of went around that.
So these three components together were part of a map that Brooke showed me, or maybe, I don't know who brought that one, but, and so they're inset maps, each one, this is the larger picture of the area in the Northwest Territories where the rock was found, and then zooming in on the Acasta River, and then that hexagon shape there expanded here to show even more detail of the location. And then I love that idea of the lines showing the cycle through, but I added the earth below it, tying into that, and then from this point, looking at an aerial view, because a lot of what I do is working from aerial views and maps. So showing the actual island where the samples were taken, and kind of breaking out of that map illustration part, and then, what did I do?
Other direction.
There we go. I really wanted an element of a hand with the rock. So, and my husband was asking me about this. I don't usually have people, like I have work that shows human influence on land, but I don't really like to have people in the work. But I really like this idea of a hand holding the sample, showing this, breaking out of the place and like taking this element, and just kind of thinking about the hands processing and working with the rock. And that's Brooke's hand. Hand model. And then, so then from the hand, the lines tie up to an image of the zircon, and it, like I said before, is really like two different types of images of the zircon, and I won't really be able to explain, but one was in like of a slice. Oh,
Oh, maybe I
we
didn't
missed
put
that
that
one.
on there. I'm
Let's see if we
sorry.
can find it.
I didn't
am I
put it
doing?
on there. I'm sorry.
We have some on
Oh,
the
that's
table.
okay. And it's up here. So next to the hand is kind of a grayscale image of
It's a thin
thin
section.
section of the rock, showing one of the zircon granules, and then the circle is showing the do you call them slide mounts or
Grain mounts.
Grain mounts. So each little dot on there kind of looks like text, but showing the lines that Emily has plotted out, all these tiny crystals, and then created an epoxy house for them. So that's kind of lumped in with that, showing the central piece, which is that zircon with the color, but also referencing the structure with the metallic stitching. So I'd kind of come up with the color version and maybe sent pictures or asked you about just clarifying, like, is this a good image to use? And I think a lot of the importance is in that structure of how the crystals formed. So I was like, well, I'm gonna combine them. And that's the only one in my sketches. I didn't sketch that one out because the process of piecing fabric, it was just felt like the most creative part of it, but also the process is not something you can sketch out. It's very progressive. You're just, that was that small piece of fabric I talked about. That's kind of pink there. that I wanted to stretch. So then I wanted the zircon to be the central focus, but then the zircon trails down, directs us to my interpretation, well, based on images of other people's artistic representation of Earth before the crust formed, also with a diagram, so both the external and then showing the inside, and then more of a modern day look at plate tectonics and that movement of crust and what did you call it?
Subduction.
Subduction.
Yeah.
So, and then back to the Earth. So I just like the idea of this cycle in scale because I love to work with scale and look for repetition of imagery at different scales. And just kind of a circle. And then Brooke mentioned it. To her, it felt like it referenced the rock cycle and just the moving through the rock cycle, moving through deep time, and moving through scale.
Hits on all of those elements.
Yeah.
I'm curious, so we didn't really get that much advance. This is our first time getting to really see this piece too with all of you. And so I'm just, as kind of our instant reflections, I'm curious to hear from our geoscientists about what they see and what their response is to this piece.
Yeah, I mean, maybe this might embarrass Annie a little, but there was a meeting a while back where we were on Zoom and Tyler and Leah and Brooke were looking at pieces in the lab together, kind of like before she'd put the whole thing together. And it was when we saw the zircon for the first time. And Annie and I were texting each other about how we were like tearing up seeing it. And I think that both of us kind of had that emotional response to just seeing both the level of detail and work that Leah has put in, and then thinking about both the earth, all of the earth processes that we've learned about, and then also the personal process of doing this research for the last number of years together. So.
Yeah, I talked about the sense of awe I had at being at Acasta, but that was more than 10 years ago for me. And so seeing all of this through Leah's eyes gave me a newfound sense of awe. You know, sometimes you get too close to something that you're not really like thinking about it in that broader sense anymore. And so stepping back from it like that was a big like emotional shift for me. And it was really helpful to kind of think about the questions that we're asking at this bigger scale, but then also the beauty of what we're looking at, and seeing it in that lens was really powerful for me.
I like all the things that Leah did, and we got a chance to see some of Leah's other work, and not just the work here, but some of the stuff that had a geology focus. Some of the things you were doing before, or kind of in preparation for this, and we talked a little bit about how our eyes as trained geologists look at things like a zircon, and like it just activates our brains. And that's what happens when I look at this. I just start thinking about things, and I could look at it for a very long time and just go around and around and around. But that is something that I won't say I like that we can do that, or I can do that without being invested in kind of trying to solve it. And that is something that, like Annie said, gives us some space. And that is really valued. It's hard for us as scientists sometimes to step back, or to not be invested in trying to find the solution to the puzzle. And this is kind of an opportunity to like step back. It's an invitation to do that for me, and I love it.
Well, yeah, thank you, Leah.
Thank you.
And look at us being so on time. I'm so proud of us. I really, I want to thank all of you for being here tonight. This has been a really special collaboration, but it's been intimate and small. It's been the 5 of us in a room talking. It's been people sitting at their instruments doing the work. It's been Leah in her studio. So it's really great to now get to share this with all of you. after I have some closing remarks, but then you'll have an opportunity. You can come up, and Leah will be over near the quilt, and she's got some of her sketches as well. And then over on this side of the room, we have some of the pieces of Acasta. We've got thin sections, grain mounts, field notebooks. So you can come and check out each of those tables and chat with these fine folks. But on behalf of the organizers of this year's Wisconsin Science Festival, they'd like to thank all the sponsors, the host venues, the volunteers, the presenters. None of it would happen without their generous support and participation. And so I encourage you to keep exploring what events are yet to come this week. You can visit wiscifest.org to find out more. Also, the next Crossroads of Ideas event is coming up on November 12th, and it's going to feature human coexistence with animals. You can add your email address to the list at the welcome table right outside those doors, or visit illuminatingdiscovery.wisc.edu to stay informed about the upcoming programs. But thank you again for being here tonight, and yeah, come up and chat.
Well done.